Welcome to another episode of Astronomy in the Backyard by Renato Biral. Today, I will present the ancient constellation of the Ship of the Argonauts, which, because of its size, was divided into three constellations: the keel of the ship, its stern, and its sail. It is also common to refer to these constellations by their Latin names. We would have the names Carina, Puppis, and Vela. Let's locate it using a representation of the 17th century celestial vault of the southern part of the sky. Interesting how old illustrations of the celestial vault appealed to the imagination, based on trippy representations. And here is the ship. Although known in ancient times, this group of stars was hardly visible from the northern hemisphere because it appeared very close to the horizon. It was only with the great navigations that a notion of what the southern part of the sky would be gained. I will now identify the three parts of the ship. Let's consider the stern first. In this illustration by Hevelius, this back part appears all pretty. The next constellation that could come would be, well, the ship itself. The keel, which would be the bottom part. The wooden one, but in the shape of a basin. And lastly, we would have its sail. The little stars of this constellation sort of outline a big circle, which might be better understood as an open sail. At the time of Hevelius, one of the parts of the ship was suggested to be named the Oak of King Charles II. Legend has it that, inside this oak, Charles II hid during a battle that was unfavorable to him. But it turned out that that region was actually associated with the keel of the mythical great ship of the sky. Nicolas Louis de la Caille was an astronomer who established several constellations of the southern celestial hemisphere. It was he who proposed the dismemberment of the great ship. In fact, he separated a fourth part of the ship, but called it the compass, one of the several nautical instruments that he ended up paying homage to. Let's now superimpose a real star map with that illustrated representation of the 17th century. For that, I'll use an app that's available in the Apple Store, which, in turn, is based on a famous celestial atlas. Note that the ship constellation is so large that the celestial vault needs to be represented with a relative curvature. After all, just to present the entire ship, 1/4 of the sky is needed. And here's the superimposition with Hevelius illustration. Seen from the southern hemisphere, the region of the great ship covers such a large extension of the sky that it takes a few hours for the ship to show itself in its entirety. The first part of the ship that appears above the horizon would be its stern. Usually, the stern is located in the sky using other more famous constellations, with brighter stars, like the constellation of Orion. Or another one that appears somewhat close, which would be the constellation of Canis Major. Remembering that, in Canis Major, is Sirius, the brightest star in the sky. In the ship, down below its stern, we would have the keel part that is closer to the end of the ship. And it is in this part of the ship that we have the star Canopus, which turns to be the second brightest star in the sky. This star was known in ancient times, but its visibility was greatly impaired by its position so far south. In fact, even at the latitude of ancient Egypt, Canopus appeared very close to the horizon and for only a few hours. In the next stage, we have the ship more on display since appears the set of stars called the false cross, which is central to the big ship. When we have the easily identifiable false cross, Sirius and Canopus become more visible, high up in the sky. The stars of the false cross, well, they end up forming a cross. This cross would be basically composed of 2 stars from the Keel constellation and 2 stars from the Sail constellation. However, the false cross is much weaker and more deformed than the true cross, which would be the constellation of the Southern Cross, which appears a few hours later. The false cross, although oriented similarly, is actually somewhat ugly compared to the beautiful set of stars that make up the Southern Cross. so much so that no country adopts the false cross on its flag. And when we finally have the Southern Cross clearly visible, the big ship is shown in full, flanked between the Southern Cross, which has just positioned itself high in the sky, and the constellation of Canis Major relatively far from the Southern Cross. As previously mentioned, the big ship comprises a huge region of the sky, with the ship arranged around the stars of the false cross. In this region, full of stars, are located the three brightest stars in the sky, all located in the southern celestial hemisphere: Sirius, Canopus, and Alpha Centauri, actually a double star and the closest star system to the Sun. Strictly speaking, the star closest to the Sun is an extremely faint star, located quite far from this system, although it is gravitationally associated with it. It's interesting how this band of sky, centered around the big ship, is full of stars. Not only the three brightest stars, but several other bright stars are also located there. It is also impressive how, even though he had never left Poland, Hevelius had this region of the sky reasonably well described. Now let's try to get a little more information about the ancient ship constellation. Let's structure it around the false cross. If the ship is well visible above the horizon, we can appreciate Canopus positioned to its right. First, we complement the region with stars that have a brightness equivalent to that of the false cross. Now, I take the opportunity to sprinkle some stars that would be visible in an urban backyard. We now have the modern borders of what would be the region of the ancient ship constellation, and its border with a bunch of neighboring constellations, most of them quite obscure and exotic. We have the Canis Major constellation, the Southern Cross constellation, Unicorn, Hydra Female, Compass, Dove, Painter, Flying Fish, Chameleon, Fly, Centaur, and Air Pump. And finally, in the 18th century, the division of the ship region proposed by Keel into the current three modern constellations: the Sail constellation, the Keel constellation, and the Stern constellation. For completeness, I will include some fainter stars and their respective guidelines that facilitate the location of these constellations in the sky. Those of the Stern, which, actually, only has one brighter star. Those of the Sail, which contains more stars. Here are their guidelines. Now you can see the open sail and the stars of the keel. In fact, the region of the keel near the Southern Cross is quite interesting, and, imagine this, it is precisely that obsolete constellation of Charles II's Oak. Here are its guidelines, and the region of the Oak Cup is not even part of it. Finally, a representation of a vessel, to give an idea of what would have been represented in this region of the sky. This vast expanse of sky is indeed very full of stars, and not every part of the celestial dome is like this. Over time, one can observe that along these regions, large voids of stars with rather faint constellations appear. The fact is that these well-starry regions are typically superimposed on the spiral arms of the Milky Way. The Milky Way is distributed throughout the entire 360 degrees of the celestial dome, but for a representation of a spherical surface on a plane, some type of projection is used. What is shown here is the Milky Way projected onto a cylinder, making it easier to show how the Milky Way is seen in the night sky. Almost the entire night sky is in the photo. Here, the center of the galaxy is shown, located in the constellation Sagittarius. And here, I take the opportunity to show where the stars of the Southern Cross would be, as well as Sirius and Canopus. And, finally, the constellations of the Keel, sail, and stern. I think it was well demonstrated that the Milky Way does indeed pass through the starry region of the ancient Great Ship. But there is a particularly cool detail that I would like to share with you. On a relatively dark night, the highlighted region always appears brighter than the neighboring regions. It's the site of the Milky Way in action. But this region is special because it is where the Eta Carinae nebula is located, as well as several open clusters. It will take some work to talk about all of this, but I promise you will be surprised. Let's start by talking about what the so-called open clusters would be. When stars form, they rarely form alone, but rather in small groups. The process takes millions of years, but once formed, these groups of stars move together through the spiral arms until they slowly begin to disperse. Stars are born from the condensation of pockets of extremely rarefied gas that are distributed in the plane of the spiral arms of a galaxy. The density of gas in these pockets is so small that it is still several times lower than the best vacuum produced in the laboratory. However, these pockets have gigantic extensions, and therefore a lot of gas available for star formation. Now, I'm going to show you 3 representations of the Milky Way. The first is practically an artistic representation seen from above, a view we cannot have, given that we are inside its spiral arms. The second is the previous representation, superimposed on pockets of gas located in the plane of the Milky Way, as detected through studies with radio telescopes. And the third is these pockets of gas along what is currently a probable structure of the spiral arms of our galaxy. To understand what open clusters are, one must keep in mind that these sets of stars actually take a long time to form, but once formed, they start to break apart over time, spreading their stars. Certainly, our Sun, when it was formed, must have had many traveling companions nearby, but now it is alone. In really, open clusters have a lifetime that we can even call short. After all, the cohesion time of open clusters, of a few 100,000 years, is practically a blink when considering the time scales involved. In fact, a way to map the spiral arm structure of our galaxy is to select, from the various known open clusters, only those that have, in quotes, just been formed. After all, if they have just been formed, they are not so far from the molecular cloud from which they originated. Note that, in the vicinity of the Sun, there is a kind of bridge between 2 spiral arms. Our Sun is not located in the spiral arms, but along this bridge, called the Orion Spur. And how to know the age of an open cluster? Remember that, in it, all stars must have the same age, but since the hottest stars live less, their absence indicates the age of the cluster. I will now give some examples of open clusters easily identifiable in the night sky. For this, I will use the constellation of Orion, which is easily recognized because of the Orion belt. In this case, I am representing Orion when it rises in the night sky. In the months of November and December, this happens, more or less, when it gets dark. Very close to Orion, preceding it by about an hour, we have the constellation of Taurus, that Taurus, from the zodiac signs. The fact is that the constellation of Taurus not only has one famous open cluster, but it has 2. The first one is the Bull's Horn, the closest open cluster to the solar system, called the Hyades. It is so close that the grouping of its stars is easily visible to the naked eye. In the Hyades, there is the beautiful orange star Aldebaran. It is at the top of the horn, remembering that from the southern hemisphere, we see constellations upside down compared to the representations made in the northern hemisphere. And the second open cluster of the Taurus constellation consists of the very famous Pleiades. They precede the Hyades by just over half an hour. As a curiosity, the Pleiades make the logo of the car brand Subaru, a word that, in Japanese, means gathering. In this photo, we can appreciate, in addition to Orion, both the Pleiades and the Hyades. Although we can see a few stars with the naked eye, these two open clusters, quite young, consist of large groupings of stars that move together through the sky. Aldebaran is a giant orange star and, because it is relatively close, appears quite bright, but it should be added that it is not part of the Hyades, whose stars are somewhat further away. Let us now talk about the Eta Carinae region. In fact, I have mentioned this region before. The obsolete constellation of Charles II's Oak was proposed by Edmund Halley, the same one of the Halley's Comet. Hevelius even depicted it in his Uranographia, but the fact is that this constellation didn't catch on and was soon forgotten. Sir Halley must have had some kind of ulterior motives because, as mentioned before, the region of the Oak Cup is precisely where the Milky Way appears particularly beautiful and milky. But it's a region of faint stars, among them a very special one which is the star Eta Carinae. Let's move on to a more astrophotographic representation of this region. For this, I'll use an important reference when it comes to mapping the night sky. Note that as it's a region located on the plane of the spiral arms of the Milky Way, there is no shortage of stars to show. Oops, we're back to the faint stars that were already being shown. Here they are, superimposed on the cartographic representation of this region. To give an idea of scale, I'll place on this cartographic representation. First, the full moon. And then the Pleiades, which we talked about earlier. The important thing is to note how this milky region is relatively large. Now, a first piece of information. Part of this milky character is due to several open clusters which, to the naked eye, have the appearance of a fuzzy little cloud. Let me separate some for you. Many of these are a real treat to see through a telescope. But part of this milky character, in fact, happens due to a real diffuse little cloud. That is the Eta Carinae nebula. There are even several stars in this nebula, but the star Eta Carinae, which is inside this gas volume, is, let's say, different from anything you've ever seen. More information about this special star, in a moment. Another peculiarity of the objects in the Eta Carinae region that's interesting is that they are very far away from here. Let's go back to the representation of the Milky Way seen from above, with the Sun superimposed on the Orion Spur. And let's remember that almost everything that is seen in the night sky is in a very small part of this structure. However, when we consider the region of the Eta Carinae nebula, almost everything we're seeing when looking in the direction of the cup of the obsolete Oak constellation is located much further away, over the Sagittarius Carina spiral arm. In fact, that would be the position of the Eta Carinae nebula when viewed superimposed on a model of spiral arms of the Milky Way. I will also separate some of the several open clusters that I've already shown and that also lie in the structure of this spiral arm. 1, 2, 3, 4, 5, and 6. One, 2, 3, 4, 5, and 6. Although, in fact, not all of the open clusters shown are located that far away. 7, 8, and 9. 7, 8, and 9. Now we can add some interesting information about the region of Eta Carinae that can be seen in only a few places. Let's go back to the representation of the Milky Way as seen in the night sky, but projected onto a cylindrical surface. By coincidence, this milky region is not only the location of several distant open clusters and the enormous Eta Carinae nebula, but it is also a region of the sky where the Sagittarius Carina spiral arm reaches its greatest angle of opening. In other words, it's where we have a tangent of this spiral arm. As we move away from the Sun, the curvature of this spiral arm causes its stars to overlap over those that preceded it. The meaning of tangent is easier to understand when the representation of the Milky Way is shown from above. The tangents, determined by radio telescopes, provide information on both the number of spiral arms in the Milky Way as well as its structure. Could the Milky region in the Eta Carinae area be due to this overlapping of stars, at least in part? Well, it's a possibility. To conclude, do you remember when I said that Eta Carinae is different from everything out there? Normally, stars in the sky appear the same way, night after night, although in ancient times there were exceptions, as a few stars were known to exhibit regular variations in brightness. In the 17th century, Hevelius represented Eta Carinae as a somewhat weak little star. But in 1827, William Burchell, a British naturalist on expedition in Brazil, noticed and reported that Eta Carinae, now somewhat reddish, had the same brightness as the brightest star in the Southern Cross. The fact is that no one in the Northern Hemisphere could see Eta Carinae, and in the 19th century there were not many observatories structured in the Southern Hemisphere. Eta Carinae's evaluations were made by several people and in a visual manner. It took a long time for all of them to be gathered. In the most complete compilation, from 2011, we have 3 particularly interesting periods. A brightness increase between late 1837 and early 1838, when it even surpassed Alpha Centauri's brightness. Another brightness increase in early 1843, where it happened again, for a longer time. And a huge brightness increase in late 1844 when, this time now, Eta Carinae became brighter than Canopus. Imagine this. Eta Carinae, that star that is even somewhat insignificant, dethroned Canopus for a whole month. We had, still in first place, Sirius. Then, the sensation of the moment, Eta Carinae, somewhat reddish, but only visible to those in the Southern Hemisphere. And then behind, eating dust, Canopus. It's okay, it was only for a short time. And worse, what wasn't even imagined at the time is that Eta Carinae was located absurdly far away, practically in another spiral arm of the Milky Way. In the Middle Ages, the first records of stars that appeared out of nowhere occurred, but after a few days, they disappeared. To these stars were given the designation nova, when, in reality, the star undergoes a huge eruption, but then returns to what it was before. Or supernova, rarer and much brighter, but it was later found that occurs when a star explodes. As a matter of fact, starting in 1844, the brightness of Eta Carinae began to decline, and it disappeared from the sky about 25 years later. So, was Eta Carinae a supernova? But how did it explode and still shone for decades? It was estimated that it must have been enormous, having about 160 solar masses when it began to shine. Stars this absurdly large are known have extremely short lives. What's even more unbelievable is what happens in the continuation of this story. Eta Carinae, slowly, returned. As astronomer Augusto Daminelli, currently retired from the Institute of Astronomy, Geophysics, and Atmospheric Sciences at USP, said, Eta Carinae is a star that shouldn't exist. At one time, in the early days, they were the main stars, but currently, there shouldn't be any. But the fact is that it still exists, it's there. Professor Daminelli will forever be associated with Eta Carinae. In 1996, he established that Eta Carinae was not one but two stars, and the interaction of this second star is the cause of a periodic brightness variation of 5.5 years that was already known. In fact, the second star is also enormous and, at the closest point in its orbit, even enters Eta Carinae's photosphere. However, from so far away, it has not been observed yet, and it is only known for its effects on the main star. And this is a photo of Eta Carinae taken by the Hubble Space Telescope. This nebula outcome of the ejection of about 45 solar masses is the result of the eruption period of the 19th century. Called the homunculus nebula, it is relatively difficult to see with a telescope, but, even though it is tiny in the sky, it still hides Eta Carinae, which is inside it. That is, Eta Carinae did not disappear because it exploded, but rather because it was obscured by that enormous mass ejection. That, nowadays, it is known that it is dissipating. Since 1980, Eta Carinae has become visible to the naked eye again, and currently shines almost as brightly as during Hevelius' time. Will Eta Carinae ever show itself in its fullness? Will it explode again? And what about you? Will you miss the chance to look at Eta Carinae this night? Thank you very much for your attention.